Hi guys. So this is going to be the screencast, kind of an explanation for the lesson on counting gas particles, the measurement of a mole. So the main thing with this lesson is I want you to keep in mind like ratios. I want you to think about comparing two things together. So if I look at how much of A I have and comparing it to how much of B, substance B that I have. Most of the practice problems within this lesson are going to have you do that analysis where you're going to see what happens if I combine A and B together to get a C amount. What happens if I double A? What happens if I double B? Or what happens if I need to double C? What am I going to have to do to A and B? Like you have to think about it in terms of drawing that picture. So if I have A plus B equals 15 grams, well, how much A and how much B would I have to get to 30 grams? Like it's really not complicated. You just have to step back and think, okay, to get to this point, what do I have to do to these? So that's kind of my little spiel for you on this lesson. We're going to be doing 4 lessons on stoichiometry over the next 2 weeks. So you're not going to have a test this week. You won't have a quiz or a test until next week. So my advice to you would be to take notes, write down some example practice problems, and make sure you have those handy because we're going to be building these 4 lessons build on each other. So we're going to take the stuff that we learned today, the skills we learned in this lesson, and apply it to the next lesson. So I'm just real quick going to show you a board that I made to kind of summarize all of this stuff. So what we're talking about here is a mole. Well, what the heck is a mole? A mole is just a counting unit. So if I said that I had a mole of people, a mole of pencils, a mole of atoms, a mole of anything, it means I have 6.022 times 10 to the 23rd of that. Um, this is called Avogadro's number. He determined that a mole of gas at standard temperature and pressure that weighs 22.4, or that has a volume of 22.4 liters. That's what STP is, by the way, standard temperature and pressure. Has 6.022 times 10 to the 23rd particles in it, like gas molecules or particles in it. So it's just a counting unit. It's just like me saying I have a dozen is 12 or a ream is 500. Now, a mole of people obviously has different mass than a mole of pencils, than a mole of atoms, than a dozen donuts has a different mass to it than a dozen people. These are counting units, and then they're going to have different masses according to whatever you have. When you think about it in terms of atoms, like atoms of oxygen are way bigger than atoms of hydrogen. So the oxygen, if I have the same number of them, oxygen's going to weigh more. So why do we have to use this big of a number? Because atoms are very small. These things are too small to count. You're not going to say, oh, I have 5 atoms and put that on a scale or a balance. We have to work in terms of this. We have to work in terms of moles and go, okay, if I have 6.022 times 10 to the 23rd atoms, how much does that weigh? If I asked one of you guys to go get me a mole of hydrogen or go weigh out a mole of iron, you could do that using the periodic table. So that's the nice thing is 1 mole, because those atoms are small, they're too small to count. We are going to use the masses on the periodic table to help us take to convert from atoms to moles, and then from atoms to moles to grams, which is what you can actually put on a balance. So if I said, somebody in class, go get me a mole of oxygen atoms, you would be getting me 6.022 times 10 to the 23rd oxygen atoms. When you put that on a balance or a scale, it would only weigh 15.9994 grams. How do I know that? Because that's oxygen's mass on the periodic table. So what's nice is if you have your periodic table in front of you, you know how much a mole of those atoms weighs. So a mole of hydrogen, for example, weighs 1.0079 grams. Sulfur, I believe, is 32.09 grams. 40.08 grams is sodium. So if I said, go get me a mole of sodium, you would go weigh out 40.08 grams. And then you would look at that and go, oh my gosh, in that sample, there's 6.022 times 10 to the 23rd atoms in there. So it's kind of cool. It relates all of it together. So how do you find the mass for an atom? For an element, you just look on the periodic table. How do I find it for a compound? I just add them all up. So I'm just going to add it together. So H2O, if I was looking at the mass of a mole of water, I would have 1.0079 times 2 because there's two hydrogens plus 15.9994 because there's one oxygen, and I would get like 18.09. So it's really cool that we can figure out like 1 mole of water. So 6.022 times 10 to the 23rd water molecules weighs about 18 grams. Um, so that's kind of the lecture portion of it. There are some example problems that it takes you through. And I want you to read through these problems because it really does break down how to analyze a chemical reaction. And my hint to you is you have to read some of the analysis to answer some of the questions. It gives you questions that can be answered by going back and looking at some of the reading in those chemical reactions that it gives you. So there's my hint. So if you're looking at like this chemical equation right here, so they give you this first one of two hydrogens. So hydrogen and oxygen are both diatomic, meaning they exist in pairs in nature. But I need two hydrogens for every one oxygen to give me two waters. So they tell me in like this little analysis thing that I have 6 grams of A. I need 6 grams of A to make 3 moles of A. So for A, it tells me that that right there has a mass of 2 grams per every 1 mole. If 6 grams or if 3 moles weigh 6 grams, then I just reduce that down. I'm thinking in terms of ratios. I'm thinking in terms of fractions. And I want you to think this way because when you're looking at those practice problems, so I've done a couple of them here. These aren't all of them. I skipped quite a few of them, but I have done some of them for you. So it gives you the box of A, B, and C, and it tells you that A has a mass of 10 and B has a mass of 5. And so C is A plus B together. So it asks you, what's the ratio, the mass ratio of A to B? Well, what's 10 over 5? The mass ratio would be 2. So um, that's going to be the ratio between A and B. Another one asks you if A plus B, or how much of A would you need to have 30 grams of C? Well, it gives you in the basic problem that A is 10 grams and B is 5 grams. So if I add those together, I get 15 grams. Well, I want 30 grams in my answer. So if I double one, I'm going to have to double the other one because they're in a one-to-one relationship. So if I double A and I double B, A ends up being 20 grams, and so that's your answer there. And then the next one asks you what B is. So you just have to think about, what do I have to do to A? What do I have to do to B to get C to be this? There's another one that asks you about uh, ones that aren't so intuitive that you can kind of do in your head. It gives you the relationship of 10 grams to A. If there's 10 grams in A and 5 grams in B, so that ratio is 10 over 5. But it says how much A would you have to have if you only had 7.5 grams of B. So you set it up as A to B equals A to B, and you're solving for X. So you would just cross multiply. So 10 times 7.5 divided by 5, and that's going to tell you what X is. And then you can set up each one of those like that. So it's not complicated, but you have to think about it a little bit, and use those example practice problems that are given to you in this reading, because like I said, we're going to build on this. We're going to be using dimensional analysis again. We're going to be using stoichiometry, which is basically dimensional analysis with chemical reactions. So just be thinking about ratios and comparing one substance to another substance. If I double one, what happens to this one? Well, what's their relationship? Are they in a 3-to-1 ratio? Are they in a 2-to-1 ratio? So you're going to have to be able to use chemical equations to determine what happens to the amounts of reactants and products that we have in chemical reactions. So if you have any questions, please let me know.